For centuries, we have explored the universe using telescopes, peering into the vastness of space to uncover its secrets and maps. We charted the stars, predicted eclipses, and landed on the moon. These achievements have been monumental, pushing the boundaries of human knowledge and capability. But there's a new frontier emerging. It's not out there in the vast expanse of space. It's a frontier that promises to revolutionize our understanding of the universe and our place within it. It's right here, in the realm of the very small, the quantum world. This is a domain where particles can exist in multiple states at once, and where the traditional laws of physics seem to bend and break. This is the realm where the laws of physics as we know them begin to blur. It's a place of incredible potential and profound mystery, where the smallest particles can have the biggest impact. This is where a new breed of computers is being born, quantum computers. These machines harness the strange and powerful properties of quantum mechanics to perform calculations that were once thought impossible. These are not just faster versions of our current computers, they are fundamentally different. They operate on principles that defy our everyday experiences, opening up new possibilities for computation and problem solving. Quantum computers hold the potential to unlock mysteries that have baffled scientists for generations. They could help us understand the complexities of the natural world in ways we never thought possible. They promise to revolutionize industries, from medicine to material science. Imagine being able to simulate the behavior of molecules to design new drugs, or creating materials with properties that we can only dream of today. But they also challenge our very understanding of reality itself. The quantum world is strange and counterintuitive, forcing us to rethink our most basic assumptions about how the universe works. Imagine a future where diseases like cancer and Alzheimer's become relics of the past. Quantum computing could lead to breakthroughs in medical research that save countless lives and improve the quality of life for millions. Imagine a world where new materials pave the way for cleaner energy and faster space travel. Quantum computers could help us develop technologies that reduce our environmental impact and open up new frontiers in exploration. This is the promise of quantum computing. It's a promise of a future where the impossible becomes possible, and where the limits of our imagination are the only boundaries. Are you ready to step into the future? The dawn of quantum computing is upon us, and it holds the key to unlocking a new era of discovery and innovation. The heart of our digital world lies in the humble bit, a tiny switch that can be either on or off, representing 1 or 0. These bits are the fundamental units of information in classical computing, forming the basis of all the data we process and store. From the simplest text file to the most complex video game, everything boils down to these binary digits. These bits are the building blocks of everything we do on our computers. They are the language of our digital age, enabling communication, computation, and control in countless devices and systems. Without bits, the digital revolution that has transformed our world would not be possible. But in the quantum realm, the rules are different. Here, the classical concepts of bits and binary logic give way to the strange and fascinating world of quantum mechanics. This is a realm where particles can exist in multiple states at once, and where the act of observation can alter the state of a system. Here we encounter the qubit, the quantum bit. Unlike classical bits, qubits are not limited to being just on or off. They can exist in a superposition of states representing both 0 and 1 simultaneously. This unique property is what gives quantum computers their extraordinary potential. Unlike its binary cousin, the qubit can exist in a state of superposition. This means that a qubit can perform multiple calculations at once, vastly increasing the computational power available for certain types of problems. Superposition is a key feature that sets quantum computing apart from classical computing. Imagine a coin spinning in the air, not yet landed on heads or tails. This is a simple analogy for superposition. The qubit exists as both 0 and 1 simultaneously. But it gets weirder. In the quantum world, particles can also become entangled, leading to even more astonishing phenomena. That's superposition. The qubit exists as both 0 and 1 simultaneously. But it gets weirder. Qubits can also become entangled. Entanglement is a phenomenon where the state of one qubit is directly related to the state of another, no matter the distance between them. Qubits can also become entangled. This means that the state of one qubit is instantaneously connected to the state of another, even if they are light years apart. This mysterious connection is what Einstein famously referred to as spooky action at a distance. Imagine two of those spinning coins now mysteriously linked. When one lands on heads, the other instantly snaps to tails, no matter how far apart they are. This is the essence of entanglement, a deep and puzzling connection that defies our classical understanding of the universe. When one lands on heads, the other instantly snaps to tails, no matter how far apart they are. This instantaneous connection is what makes entanglement so powerful and intriguing. It opens up new possibilities for communication and computation that were previously unimaginable. This is the power of entanglement. It allows quantum computers to solve problems in ways that classical computers cannot. By harnessing the unique properties of qubits, quantum computers can perform complex calculations at unprecedented speeds. These strange quantum phenomena, superposition and entanglement, give quantum computers their incredible power. They enable these machines to tackle problems that are currently intractable for classical computers, such as simulating molecular interactions for drug discovery or optimizing large-scale logistical operations. They allow these machines to perform calculations in ways that classical computers simply cannot. As we continue to explore and develop quantum technology, we are on the brink of a new era of computing that promises to revolutionize science, industry, and everyday life. Think of searching through a maze. Imagine the complexity and the time it would take to find your way out if you had to explore each path individually. A classical computer, like a lone explorer, would have to try each path one by one. It would methodically go through each possible route, checking and rechecking until it finds the correct one. A quantum computer, with its qubits and superposition, could explore all paths simultaneously. This means it can process a vast number of possibilities at once, drastically reducing the time needed to find the solution. It's like having a million explorers working in tandem, each taking a different path and sharing their findings instantly. The power of parallelism in quantum computing is truly revolutionary. Or imagine trying to find a specific grain of sand on a beach. The sheer number of grains makes this task seem impossible. A classical computer would have to sift through each grain individually, examining each one until it finds the target. This process could take an enormous amount of time. A quantum computer, on the other hand, could analyze the entire beach at once, instantly pinpointing the target. This ability to handle vast amounts of data simultaneously is what sets quantum computing apart. These are just simple analogies, but they illustrate the fundamental difference between classical and quantum computing. While classical computers are limited by their sequential processing, quantum computers leverage the power of parallelism. It's not just about speed. Quantum computing opens up new possibilities for solving problems that were previously thought to be unsolvable. It's about tackling problems that are impossible for even the most powerful classical computers. These include complex simulations, optimization problems, and cryptographic challenges. Quantum computers won't replace our laptops and smartphones. They are not designed for everyday tasks like browsing the internet or running simple applications. Instead, they will be used for specialized tasks that require immense computational power, like simulating complex molecules, optimizing large-scale systems, or breaking sophisticated encryption codes. The future of computing is quantum, and it promises to transform the way we solve the most challenging problems. Quantum computers are still in their infancy. Building them is like trying to build a house of cards in a hurricane. The very quantum phenomena that give them power also make them incredibly fragile and prone to errors. Keeping qubits in a delicate state of superposition requires extremely cold temperatures, colder than the vacuum of space. Even the slightest disturbance can cause them to lose their quantum properties, leading to errors in calculations. Overcoming these technical challenges is a monumental task, but scientists and engineers around the world are making progress every day. They are developing new techniques to control and manipulate qubits, paving the way for more stable and reliable quantum computers. The quantum revolution won't happen overnight. It will be a gradual evolution, with each breakthrough bringing us closer to unlocking the full potential of this revolutionary technology. So let's dive into the fascinating world of quantum mechanics. It's a field that promises to revolutionize our understanding of the universe. Quantum mechanics, you see, operates on principles that are, well, quite different from classical physics. At the quantum level, Particles can exist in multiple states at once, a phenomenon known as superposition. And there's also entanglement, where particles become interconnected and the state of one instantly influences the state of another, regardless of distance. These principles, though they may sound a bit, mind-boggling, hold the potential for groundbreaking advancements in technology, from quantum computing to secure communication. The promise of quantum mechanics is indeed vast and full of possibilities. As nations and corporations alike vie for supremacy, the quantum race intensifies. The stakes are higher than ever before. Each breakthrough, each discovery, brings us closer to a new era of technological marvels. But with great power comes great responsibility. Who will emerge as the leader in this quantum quest? Imagine a world where the boundaries of reality are no longer constraints. Quantum mechanics offers us the tools to break these chains. From teleportation to unbreakable cryptography, the possibilities are boundless. But how far are we willing to go? And what ethical considerations must we address as we push the limits of what's possible? The future is being forged in the fires of quantum innovation. Industries will be revolutionized, economies transformed, and societies reshaped. Quantum computers could solve problems deemed unsolvable, and quantum networks might offer unprecedented security. Yet this future is not without its challenges. How will we navigate the complexities that lie ahead? As we stand on the precipice of a quantum revolution, we must reflect on the legacy we wish to leave. The decisions we make today will echo through generations. Will we harness this power for the greater good, or will we fall prey to the pitfalls of unchecked advancement? The legacy of the quantum age is ours to shape. Thank you for watching. Please like and subscribe for more videos.